Okay, so definitely make sure you know these three just kind of definitions. There's other ones that are important, but these are ones just to highlight. Um, you know, if a study is biased, it's going to systematically, miss the mark. It's going to underestimate or overestimate the value you're trying to find. Random assignment, we talked about that, creates roughly equivalent groups, which help avoid confounding and can lead to cause and effect conclusions. Um, and again, statistically significant. If you compare your results to a simulation, and it's pretty unusual, less than 5%, you're like, I think this is causing it, right? We statistically significant proves causation there. Okay. Number one, a department store mails a customer satisfaction survey to people who make credit card purchases at the store. This month, 45,000 people made credit card purchases. People made credit card purchases. Oh, that was weird. Uh, Surveys are mailed to 1,000 of these people. Chosen at random, 137 people return the survey. Identify the population and the sample. Okay, so the population, all people who made credit card purchases. So it seems like we're picking from not all people who made credit card purchases, but the 45,000 seems to be the population here. Okay, so I think we're down to these two. I think these three are out, just my population. Um, then the sample, so I got confused on this one. So surveys are mailed to 1,000 people. So you would think, oh, we're sampling 1,000 people, but only 137 returned. So this is actually the sample size. So the 137 people. So it's got to be D. Okay, so bias. We just went over the definition of bias. We should have been paying attention. So what is bias? So any difference between the estimate from a sample and the truth. No, I don't think so. Any difference between the estimate from a sample and the truth about the population due to using chance to select a sample? Sounds like you're doing a simulation, but that's not what bias is. Any difference between the estimate from a sample and the truth about the population due to practical difficulties such as contacting the subject selected? Any difference between the estimate from a sample and the truth about the population that tends to occur in the same direction when you use the sampling method? So that is definitely, it tends to be either, bias is always underestimating or overestimating the population in one direction or another. Yeah, that's it. Researchers wish to determine if new experimental medication will reduce the symptom of allergy sufferers without the side effects of drowsiness. That is the worst part about allergy medication is it makes you tired sometimes. I think I've taken it so long I've overcome that, but I don't know. To investigate this question, the researchers randomly assigned 100 adult volunteers who suffer from allergies to two groups. They gave the new medication to the subjects in one group from an existing medication to the other groups. They were randomly assigned. That's good. I like that. 44% of those in the treatment group and 28% of those in the control group reported a significant reduction in their allergy symptoms without any drowsiness. The experimental units are the So who or what are we studying here? So randomly assigned. So there were adult volunteers who suffer from allergies. Okay, so the 100 adult volunteers seems reasonable to me. Mr. Miller wants to study the effects of storage time, 6, 12, and 18 months, on the amount of vitamin C present in the freeze-dried fruit when stored for these length of times. 6 fruit packs were randomly assigned to each of the 3 storage times. The treatment, experimental units, and response are respectively. Ooh, a lot of choices here. Okay, so the treatment. So, what is the treatment? Well, we've got 3 different, is it the length of time there that it's being stored? So, uh, I think these 2 are out. The treatment seems to be a specific storage time. The experimental unit. So who or what are we studying here? Ooh, and it says, this is interesting. It says experimental unit, not units, which makes me think it's just one of them. And actually there were 6 fruit packs there's actually 18 fruit packs. So I don't think that one quite makes sense, although it's tempting. The amount of vitamin C, no, that's definitely not it. It's a fruit pack. And finally, the response, that what you're measuring is the amount of vitamin C, right? So one of those would have to be it. So the correct answer is D. You're measuring the amount of vitamin C there. The principal reason for the use of random assignment in designing experiments is that it, remember, I want you to know 2 things. Roughly equivalent groups creates cause and effect. Creates approximate equal groups for comparison. That's got to be it. I mean, let me just double check the thing about causation. Yeah. Okay, a local tax reform group polls the residents of the school district and asks the question, do you think the school board should stop spending taxpayers' money on non-essential arts program in elementary schools? Probably a biased question, right? We're going to actually say in the question, non-essential arts. It seems like, oh yeah, I don't want to support non-essential arts, just the way it's phrased there. So people are gonna say, I don't want to support that. So underestimate for the support because of undercoverage. So I agree with underestimate, but undercoverage is when there's whole populations you're not reaching. I don't think that's the reason. Because of the way the question is worded, oh, I like that a lot. Undercoverage, no. So definitely not an overestimate. So it's got to be B. An experiment, an observed effect that is so large, rarely occur by chance, is called, that's just the definition of statistically significant right there. Psychologists study the effects of positive thinking on cognitive ability, designs the following study. 120 male volunteers are divided into 2 groups by random assignment. 80 female volunteers are divided into 2 groups, 40 by the same method. One group of 60 males and 40 females is asked to write down 3 things they feel they are good at doing, and the other group is asked to write down what they ate for breakfast. All 100 subjects then take the SAT math practice test. I like this. And the scores for the groups are recorded. Which of the following is the correct description of this study? So it seems to be an experiment, first of all. Like this is observational studies go right out the window very quickly here. They were assigned treatments, right? Different feel good about yourself kind of things, or what was the other one? Or eat a good breakfast. That's good too. Wonder which made the bigger difference. I don't know the results of the study. Which of the following is a correct? So what type is it? So is it a completely randomized? It doesn't seem completely randomized would just be half the people get it, the treatment, half the people get the inactive treatment. Like that's not what they did. They broke them into groups, similar groups, right? Boys and girls. They blocked by gender. So I think it's a randomized block. They didn't pair them up. That would be impossible. There's 40 of one, 60 of another there. So it's definitely a randomized block. Control groups are used in experiments in order to accomplish which one of the following? Comparison, maybe. They help account for the effects of variables other than the expenditure of variables. They control the subjects of study, show that they guarantee someone other than the scared. Okay, I gotta read these again because this was not as easy as I thought it was going to be. They help account for the effects of variables other than an explanatory variable on the response variable. I don't think, but I might have to consider that one again. Not crossing it out yet. Control the subjects of a study to ensure that all participants complete the study. So that's definitely not it. That's a bad answer. It's a control group, right? Guarantee that someone other than the investigators who have a vested interest in the outcome controls how the experiment is conducted. No, they have no control. Achieve a proper and uniform level of randomization. I mean, I don't think that's are used. I don't think so. Measure variability in the response variable. So control groups, when you get the placebo, they might have a little placebo effect, but they help control. Like I think A is the better answer there. So they help account for the effects of variables other than the explanatory variable. So you're part of a study. I think that is the one that makes the most sense there of those answer choices. It's not the answer I expected. I expected it to be used for comparison or something, because that's what control groups are there for. But indirectly, I think that works of those two answers. Hopefully, I'm right. 10. A published study in the New England Journal of Medicine compared two medicines that treat lice, an oral medication called ivermectin and a tropical lotion containing malathion. Researchers studied 812 people and 376 households in 7 areas of the world. Ooh, interesting. Of the 185 households randomly assigned to ivermectin, 171 were free from head lice after 2 weeks, compared with only 151 of the 191 households randomly assigned to malathion. So what is the difference? They calculated for us. That was nice. Okay, so they said the difference is, and they took those numbers and just, got the proportions and subtracted the proportion of ivermectin minus the other one and found a 13% difference there. So 100 trials of simulation were done, right? So with the overall, whatever 171, so that's 322 if you add up the numerators. If you add the denominators, that's 2, that's 376, I think. So if the chance of, getting free from lice was that, they did simulation based off that number, the total of both, and you're still going to have some variation, but how unusual is 13% in the simulation? Well, 13% is, like, here's 8%, like 13% is way out there, right? So is the difference of 13% statistically significant? Oh, so here's the question. Yeah. So yes, it does seem to be that because, no, not because it's approximately normal, although, well, simulation, but a difference of 13% never occurred in the simulation. It's extremely likely to get a difference this big due to simple chance alone. That's what the simulation is based off. It's chance alone. A football coach thinks lessons in yoga will improve the flexibility of his players. I think they may do this more. I don't know. To test this theory, he randomly divides the players on the team into 2 groups. One group has 45 minutes of yoga training each day. Players in the other group do the standard stretching routine his team has used in the past. He compares the flexibility in the 2 groups at the end of the season. Is this an experiment, a retrospective observational study, or a prospective observational study? He randomly divides the players into two groups. So this seems like a treatment, right? Isn't yoga a treatment? So this is an experiment because why? So it's experiment, you would say, because uh, the treatment of yoga was given. So it's an experiment. Comment on the extent to which inferences can be drawn about a larger population, whether the cause and effect can be established. So, were they randomly divided into groups? One group was assigned yoga, one group was not assigned or assigned no treatment there, just do the standard, I guess. So, yes. Oh, about a larger population. And so what is the larger population? So, uh, his football team or football team like his football team. Let's see what they said. I like sometimes I like to read what they say. Because the treatment was imposed, yoga training, this is an experiment. Because there was no random sampling from a larger population, the results of the experiment cannot be generalized beyond the players on the team. Oh, I like that a lot. So because there was no random sampling, so he didn't sample his team, like his team was the starting point. It's just that population. So you can only see the results apply to that team because he didn't take a sampling of many football teams or something in the area. No, he just did his team. So because there was random assignment, we can prove cause and effect. So I really like that problem just for getting ready for that. So to think about, there really was no random sampling from a larger population. He just took his team and went with that. So Michigan Stadium, also known as the Big House. It is a big house. It's bigger than Tennessee, actually. Tennessee Stadium. Has more than 100,000 fans for a football game. The University of Michigan Athletic Department wants to survey roughly 10% of the fans in attendance about concessions that are sold during the game. Tickets are most expensive for seats on the sidelines. The cheapest seats are in the end zones, where one of the authors sat as a student. A map of the stadium is shown. So here's the map. Describe how to obtain a random sample of approximately 10,000 fans using stratified sampling. Explain your choice of strata, why this method might be preferred to simple random sampling. So we have three areas, sideline, corner, and end zone. So it seems like we should stratify by area of the stands. So there are three different stratifications. Those are similar areas you might sit in, and so that makes sense to do it that way. So within each strata or layer there, so you're going to do a simple random sample, ask your questions, collect it, and then compile the data. Let's see what they said for this one for 12. Use the three types of seats as the three strata because ticket prices will be similar within each stratum, but different between the three strata. I really like that sentence. Because why? Because they'll be similar, ticket prices will be similar within each stratum, but different between the three strata. People who can afford more expensive tickets probably have different opinions about the concessions. The people who can afford only the cheap tickets. Randomly select 14 out of 44, or 31% of the 3,180 fans from the corners. 18 out of 44, or about 27%, or 2370 from the corners, and then from the that much from the end zone. I think the first one must have been from the sideline, actually. And combine these simple random samples into one sample, stratification by seat type should result in more precise estimates of fan opinion than a simple random sample of the same size. So I really like the way they said that last statement as well. By seat type should result in more precise estimates. Okay. Okay. So this one, in a long-term study, researchers collected information about the diets of participants and whether or not they developed an eye condition called age-related macular degeneration, AMD. People who ate lots of green leafy vegetables, not me, which are high in lutein and that, had a lower risk of AMD. Uh-oh. Explain how compounding makes it unreasonable to conclude that eating green leafy vegetables causes a reduction in the risk of AMD based on this study. Okay, so they collected information about the diets. People who ate So did they do? I don't think they had an experiment here. So this is just an observational study. Let's see what it says. Sometimes on these word ones, it's good to look at it. Did it say confounding? I didn't read the question carefully. Let me go back there. Explain how confounding. Oh, so obviously it's an observational study, so it's not going to prove causation. But what confounding variables? So if you are someone who eats green leafy vegetables a lot, you're kind of a healthy person, I ascertain. Maybe you're working out more, maybe you're getting more sleep, maybe you're, again, eating other healthy, like fruits as well. So fruits could be a confounding. Other healthy choices you're making. I'm assuming you're making lots of healthy choices if you're doing that. It's possible that people who ate lots of green leafy vegetables also ate less red meat, and that eating less red meat decreases the risk of AMD. If both these conditions are true, then we would see a relationship between eating and green leafy vegetables and a lower risk AMD, even if eating green leafy vegetables has no effect. Maybe it's really they're vegetarians and they avoid meat. I don't know. I mean, there's so many different things that could be confounding variables there. There's not one right answer. 14. The customer's call center for a major electronics manufacturer is trying to determine how to keep customers who are on hold as happy as possible. They want to examine whether the type of music they play while customers are on hold, whether there is not a periodically repeated recorded message, thank you for your patience, we will be with you as soon as possible, have an impact on customer satisfaction. They plan to randomly select customers who are on hold and play one of the three different types of music: smooth, jazz, classical, Broadway show tunes. Either play recorded messages or not. After the entire call is over, they will ask customers to rate their overall customer service experience. Suppose the company plans to conduct a completely randomized design. List the experimental units, the factors, and the treatments. Okay, so they have how many different types of music? So three different types. So you would randomly split the folks into three different groups. They were assigned their, let's see, they're all assigned treatments. So the experimental units are the people who call into the show, customers of this company. The factors are two different factors. Oh, I didn't think about this. So now you think about it, okay, so there were actually three different musical types, but there's also two different whether or not there is a specifically recorded message. So there's one that's a thank you for that or not, right? I think. Let me see. Yeah. So either they say that or don't, and then they do that. So, are there two of one and three of the others? Is not doing that possible? And treatments, what are the different treatments in this experiment? So combining that one with each one of those is 3. Are they saying don't do that? Let's read 14a. What does 14a say for the answer? The experimental units are customers who are put on hold. Oh, I like that description, customers who are put on hold. The factors are the type of music presence of recorded messages. The treatments are jazz message, classical message, show tunes message, jazz no message, classic no message, show tunes no message. So there is both of those. So there's 6 different ones. That's what I was leaning towards on that one. Part B. Oh wait, no, experimental design. Yeah. So part B. Suppose the company is concerned about at the time when the call is made, daytime versus evening. will have an impact on which combination of music message is most effective. How might they alter the design of this experiment? Oh, so that's a great question. I love the way they phrase it. They think there's going to be a difference between daytime callers and nighttime callers. So what do we need to do? We need to block. We need to do a randomized block, and within each block, perform all those treatments, right? So let's look at that. So they should block for the type of day when the call is made because they think there's a difference. They should randomly assign equal number of customers who call during the daytime to those who call in the evening for each treatment type, so that there's roughly the same number of customers from each time period in each group. Okay, 15. So in college, some professors allow students a full sheet of paper to use for formulas and notes during exam. And other professors only allow a 4x6 note card. Ooh. Does a larger formula sheet enhance the performance of students on the exam? Dr. Bush of Waynesboro University designed an experiment to help answer the question. The study used 50 undergraduate statistics students as subjects. Dr. Bush randomly assigned half the students to take the upcoming exam with a full sheet of paper for formulas. The other half only got a 4x6 note card. One response variable was whether or not the student got an A on the exam. Here's the table. Okay, so calculate the difference in the proportion of students that got an A between the two. So it would be, so you go 7 out of 25 minus, is it full sheet? Yeah, minus note card, minus 5 out of 25, which is a total of 2 out of 25, or approximately 8%. Okay, so 100 tries of a simulation, there you go, was performed to see which differences in proportions would occur only by chance variation. Assuming the size of the formula sheet did not affect whether a student got an A or not. So if we look at just, the overall 12 out of 50 or 24%, so that simulation is saying if it's 24% chance for either one, like just 24% chance, there's still going to be some variation there. But, how unusual is this? Well, oh, by the way, there's one dot at 32. This is just a random dot at 0.32. There it is. That means that in that random assignment, there was a difference in the proportion between full sheet group and note card group of 0.32. Use the results of simulation to determine if the difference was statistically significant. So where does 8% fall in this graph? Out here somewhere. Yes, it is, because why? Because we didn't get a result of 0.08 or greater in our simulation. And so significant, they said, because a difference of 0.08 or greater occurred frequently. Oh wait, 0.08 or greater. Wait, did I not see that? 0.08. Oh, not 0.8. Where's 0.08? That's right here. Oh my goodness. So all of these guys, that's definitely way more than 5%. So I'm glad I checked that answer. So because that occurred 43 out of 100 times, almost half the time, way more than 5%, the difference is not statistically. So let me change that if I didn't already. Yes, so this is no. Because if you were paying attention, it's not 0.8, but 0.08, and that's right there. So about half of them. You try to count it out there. So it is extremely likely to get a difference this big simply due to chance variation alone. That's your lesson.